Thank you so much, everybody, for joining us here today for our first water summit. This is kind of an exciting day for the New Britain Water Company, and just want to kind of give a little bit of a answer the question, why are we here? There's no secret that many of the questions that have been asked in the last couple of years surround around the water department. What do we do? Why are we here? What is our purpose? What is our future? And I think that there's a lot of information that needs to be told about the history of the water department, about the current projects that we have, and about where we're going. Most importantly, to emphasize, and Director Ray Esponda will do that today, the importance of a public water supply and what that means to our community and what that means to our customers and our residents. And we're hoping that thanks to Nutmeg TV, thank you for filming today, we'll be able to have this for many years to come to provide to city officials and residents who are just curious about what the water department does and the different facets of it. We're talking about the water side, but we're also going to talk a little bit about the sewer side as well. You've heard a lot in the news recently about some sewer problems that we have, and that happens when you have an aging infrastructure. And when you're talking about over 100-year-old pipes, there's a lot of work that the city needs to do to make sure that we're providing the best resources for our citizens. There's also a lot of financing that has to go into that infrastructure. We're hoping that we can talk a little bit about that today and how the city can continue putting the necessary resources into this gem that we have. So with that being said, I'm turning it over to Mark Moriarty, our Director of Public Works. Thank you all for being here.
I'm going to quickly hand this over to Alderman Don Naples. He's going to talk about the history of New Britain Water. Getting started a little bit early, but the agenda today consists of first Don Naples talking about history. I'm going to give you a brief status just about where the department's at right now. And then Director Ray Esponda is going to go through and really talk about the water asset, everything from our distribution system, our water supply, just the whole water asset, and it's comprehensive. Second part of the agenda, and I'm sure we'll get started a lot sooner than this, I'm going to talk about the sanitary sewer system, briefly hit on the storm system, and then Michelle Ryan from Mattabesset is going to talk about Mattabesset District. Probably a misconception, I think, about people that New Britain Water actually isn't just New Britain Water anymore. It's actually New Britain Water Sewer. They handle all of the city's underground utilities. So with that, I'm going to turn over to Alderman Naples.
Thank you, Mark. Hope everybody can see what's going on here. We just set this up different. The water department goes back to 1856. Our first mayor, Frederick T. Stanley, had a study performed about the feasibility of securing a water supply to the city. 1 year later, the water board was given authority to construct a water supply system, and the groundbreaking for the Shuttle Meadow and original 5 miles of water main happened in 1857, the next year. The first day water flowed from Shuttle Meadow into the system was October 6th, and notably the original bond issue for this construction was $50,000. Keep that number in mind.
It was 1857.
That was a lot of money back then.
Yeah.
So the water department was founded in 1857. The town population at the time was 4,500. And in 1868 was the first reported water shortage because of rapid population growth. If you see down here, in 1910, the population was already up to 43,916. In 1891, there was a new dam added 10 feet of height to the Shuttle Meadow Reservoir, bringing its capacity to 1 billion gallons. So, and then in 1910, it was raised another 4 feet up to 1.3 billion gallons, where it is today. 1930, our population was up to 68,000. 1938, construction began on New Britain's first water filtration plant. There's a picture of it right there. It was designed by an engineer in Silver Spring, Maryland, a guy named Robert Morse. Did the first one. It was a revolutionary thing that used fine sand for filtration. And that particular day, big day in my life, because it was August 19th, 1938, and that's the day I was born. So my father, who was working for the water department, apparently didn't show up for that picture that day. He came to work right out of college in 1929 and finished up running the department in 1969, 40 years. So I got a little family. I think that's why I was asked to do this. But that filter plant, I remember the only place they could find the fine sand they needed was from Cape May, New Jersey. They had to truck it up here whenever they needed it. 30 years later, I was in the Coast Guard. I was stationed in Cape May and learned a lot about that fine sand because it's so fine it gets in everything. It gets in your car, in your house, in your teeth. But there was no sand like that, and it was very good for this application. So in 1950, so another big event happened. New Britain was the first municipality that added fluoride to its water in New England. And there was no vote on it. There was some controversy at the time. The New Britain health inspector had been reading about people in the southeast U.S. They had fewer cavities there. It was because the natural water that they drank had very little had fluoride in it, natural fluoride. So the group got together and decided, yeah, that would be a good thing to do. We'll put 1 part per million in. Now it's a big deal whenever anybody wants to do anything. But New Britain was first in New England, and the local history room sent me an article that was in the Hartford Courant chiding Hartford for not being progressive like New Britain was. So in 1960, our population was up to 82,000. Population kind of floats through here. We got to 95,000 in the mid-60s, and we're at 73,000 today. So that has a lot to do, that and the factories, with what we use. So in 1961, there was another filter plant added, a section, the B plant. And so our total filtration capacity went up to 25 million gallons a day. That was fortunate because in 1965, they had the highest usage ever in one day. That was 21 million gallons on July 14th, right in the middle of the previous 60-year drought. The one we just had in 2016 was the next big one. 67, the Wassel Reservoir was completed, adding 900 million gallons of water storage to the New Britain system. Another thing that runs through this history, I forgot to mention a big one, it's not on here. In 1900, City of New Britain bought 1,000 acres of watershed property in Burlington. Very big deal, and still is. It was one of the most foresight items that's paying off even today, because it's 1,000 feet higher than we are here. Everything's gravity feed, no pumps needed, and all that land is still there. Sometimes little pieces of it kind of get threatened, but we still have the 1,000 gallons. Where are we? So water consumption, a lot of it when the factory heyday was commercial, and they used to keep track of it by commercial and residential. They don't do that anymore. We were about something under 50%, 52% back in '64, and by '71 it was 35%, which is interesting because between '65 and '71 was when the Route 72 went through and a lot of factories disappeared. So the industrial use today is under 15%. So in 1990, our water system was fairly settled in terms of hydrants. We have, Ray will get into it later, we have something a little more than 2,000 fire hydrants and water meters, and one number that's gone up is the miles of distribution and transmission mains. I think one of the things you'll take away from here is what an enormous infrastructure we have to deal with and how old it is. I think we're up to 270 or 80 miles of distribution and transmission mains. 2004, new $60 million water filtration plant went in. Remember the original one was $50,000. My dad said that had a life of 50 years, so it lasted 68 years, which was pretty good. Interesting fact, the Wassel Reservoir was named for New Britain native David Wassel. He was a Navy submariner who, when the Thresher went down, he was lost along with the whole crew in 1963. Until then, the original name of the reservoir was Panther Swamp, so this is a lot better.
Nice name. 2019 is a better name now.
Yeah. Should mention back in the fluoride thing, I didn't have any cavities until I left to go to college, and then got 4 in the 4 years that I was there. So this is it for me, and I did it in under 10 minutes.
You did a good job, Don.
Yeah.
Okay, I'm just going to get you up to date on where we are as a department right now. Don's presentation ended pretty much in the history of the water department in 2004 when the treatment plant was done. I have a little bit of history in the past few years since then. So for the first 155 years of its operation, New Britain Water was moving along just fine, doing a good job. They had just built a treatment plant. 2012 got thrown a little bit of a kink. And I think Bray and some of his guys might say that it was a black cloud day in New Britain Water, but it's actually been a very productive thing. That's been a great thing for the city because we actually did a lot of savings by merging operations. But in 2012, we merged all of our utility operations under New Britain Water. So our sanitary sewer system and our storm water drainage system, all the staff that went along with that, all the equipment came into New Britain Water. It was a good move because just being in public works, sanitary sewer, it was managed as one of our functions, but New Britain Water really manages underground utilities. So it was a smart move, and it's a move that we continue to make progress on. What this meant, just for a couple things that this meant for New Britain Water, added 333 miles of pipe under their management. Almost 8,500 structures between manholes and catch basins was added to New Britain Water for things that they needed to oversee. And both water and sewer utilities, they have heavy permitting requirements. There's a lot of deep permitting, a lot of work we have to do just for compliance. And especially on the sanitary sewer side, there's massive capital investment required. So I'll get into that probably more in the second half of this presentation. But sanitary sewer have to do a lot of capital projects. It's been successful to date. Ray and I are joined at the hip. Spend more time with Ray than do my kids, girlfriend. For all the time we spent together, I say we generally like each other. Basically, and New Britain Water, when it first came into public works, it was pretty, actually I gotta say it was a pretty easy task for me. It came with a full management team. Bill Bly was there. There was it didn't really require a heavy lift on my part. And then 2016 happened. Going into 2016, org chart was pretty solid. Then within that year, we lost 3 of the top positions in utility operations. This is on the distribution side. This is the water quality side at the beginning of 2017. And similarly, lost a number of our top positions in during the course of 2016. Overall, in 2016, we had 5 of the top 7 people that we were lost through retirement. It was the water director, Gil Bly, our chief treatment plant operator, water sewer superintendent, chief caretaker, and water sewer general foreperson. So, I mean, we lost basically all of our people, and we did this at a time in 2016 where we were faced with the worst drought since 1960. Shuttle Meadow Reservoir was at 20%. At the same time, on the sewer side, we were faced with a consent order from EPA that we had to negotiate. It's a CMOM order, basically, and it spoke to how we had to manage our sewer and also the investment we had to put into our sewer moving forward. So these are probably the 2 most difficult things that we were faced with, either on the water side or the sewer side in years and years, and we were doing so with 5 of our top 7 people gone. Fast forward a few years, I gotta say, we not only got through those things, we negotiated the CMOM order favorably. It was a difficult thing to do. We got through the drought. Thankfully, the weather turned around. Actually, this year has been one of the wettest years on record, and we've been operating pretty close to 100% for quite a while now. Our new leadership team at Water consists of Reyes Banda as the lead. He's Deputy Director of Public Works. He runs the water and sewer operations. James Richardson, Chief Treatment Plant Operator. Sorry about the typo there. Chris Bolkowski's been in charge of as Superintendent of Water Sewer. Dave Camden has been promoted to our Chief Caretaker. Caretaker runs all of our reservoirs and our watershed properties. And Dave Kamaitis recently promoted to Water Sewer General Foreperson. Now, all these guys have been doing a good job. A lot of them have been acting in these roles for a while before they were promoted. And the good thing about these guys, what I'll have to say, is that they went through this. These guys went through the drought. They went through the consent order, and they've been working together as a team in one of the most difficult times in our operations. Another thing that we've dealt with is it's funny because Don was showing me something that his father wrote in the 60s. And New Britain Water, it's funny when you actually look at any of the history about issues that the city's dealing with. It's the same issues that we were dealing with. You look at something in the early 1900s, and oftentimes it's the same issues. But in a report his father wrote, they were dealing with a aging workforce, not a balanced workforce. That's something we've had. We just had we haven't had ability to succession plan, or we had too many older guys that were doing very physical work. Over the past couple of years, it's something that we've done, made a bunch of new hirings. We've really made significant process. Here's a picture of everyone in the department, but a lot of our new guys. We have 48 positions in water. There's 4 vacancies right now. Good thing about the reorganization, what brought it together, it gave more people that when you have an emergency, like you have a water main break, we can draw from sewer guys, we can draw from water guys. They can work together, and they all have experience doing this now. The rest of the presentation, really, now next Ray's going to get into our water asset, the distribution system. We have a great map over here about our water supply. So actually, this map really covers everything, but it covers our water supply system. We're going to try not get too in the weeds. This is technical stuff. It's water. We're going to try and keep it kind of high level and informative for you. Some of it gets a little technical when you're talking to water treatment plant operations. So if we do feel like we're getting technical, bear with us. Ray does a hell of a job of keeping things entertaining and moving things along. So I think you're not going to have to worry too much about that. Okay, Ray.
Thank you, Mark. Mark, it has been a pleasure working with you for the last 2 years. And you can pay me later. I've been here since the construction of the plant. I started in 2001. When I first got here, Gil Bly interviewed me and refused to show me the old plant. That's how bad it was. It had gone 16 years past its useful life. It was a steel moss plant, and I'm sorry, I went the wrong way. But as you can see, it was all steel, and the walls were originally 4 inches of steel. When I got there, they were like 3. It had just deteriorated over time. But I've been blessed to work with the foresight of the prior overseers of the water department. There were some really brilliant people at one time. They made some great decisions. Buying the land, locating the plant, putting the assets where they needed to be done. Fantastic work. I actually stand on the shoulders of giants. Don's father did some incredible work. Getting the Wassel construction, it was amazing. So I'm going to just go over the basic water utility system. I'm going to go over the supply system, quality and treatment, which is my forte. We're going to discuss the distribution system, some of the current projects and initiatives, and of course we're going to talk about our rate as compared to others in the area. All right, the city's water supply, we have a safe yield of about 17.6 million gallons a day. That's the water we can get from our reservoirs. We have 7 reservoirs. The furthest one being away is the Wigville Reservoir. We have the Walcott Reservoir. We have the Malpee. We have our Shuttle Meadow Reservoir, which is outside of our treatment plant. The Wassel Reservoir. The Hart's Ponds. There's a pair of ponds. And each one of these has a high hazard class C dam. We also have the rights, again, which I had to utilize for the first time since the 1960s, to withdraw water from the Nepog Reservoir, which is owned by the MDC, which is all the way up here. And that pipeline here is our system. We have 2 branches of supply. We have the Western system, which comes from Walcott all the way to Wassel. And then we have the Northern system, which goes from Nepog to Wigville all the way to Shuttle Meadow. And from these 2 reservoirs, we draw water into our treatment plant. We also have 2 groundwater supplies, which we're the future for the New Britain Water Department is those groundwater supplies. We have the Patton Brook, which we just got back from Southington about 3 years ago, and we have plans in place to utilize it. The first time that water has actually come to New Britain was about 1.5 years ago. We reconnected it to our system, and we were able to draw limitedly into our Shuttle Meadow Reservoir. It's connected to our Western system, but because of the aging pump and the way it was originally designed, it was intended to go into Shuttle Meadow, not into Wassel. The pumps aren't set right, and we have to do some work out there. We also have about 6,800 acres of watershed land, actually over that, and that's located throughout 6 towns in the state. We have a lot of property in Burlington. I actually talked to one of the administrators in Burlington, said that New Britain is the largest property owner and taxpayer in the city of Burlington, in the town of Burlington. And we have hundreds of miles of pipes connecting all of these reservoirs and our distribution system to the treatment plant. And we'll just move forward from there. Okay, our northern supply consists of the Shuttle Meadow Reservoir, which is our largest, has a huge capacity, 1.4 billion gallons. We also have the Wigville Reservoir, which is up here, a tiny reservoir in an incredibly large watershed. It's almost like, if you looked at it from a map, it's almost like looking at a thimble inside of a blanket. Incredibly large watershed. We also have the Whitesbridge Ponds and Pump Station. We have a pond where we get surface water, but we also have 32 wells out there, very old wells that really need to be redeveloped. And we're working right now to doing a study to see if we can actually make that a potable water supply. Okay. Then we have our Western system. And our Western system consists of the Wassel Reservoir, which is almost 1 billion gallons. The major concern with the Russell Reservoir, it's a great storage reservoir, but it doesn't have a lot of watershed on its own. So it's really dependent on the Hart's ponds, would have to be pumped to that reservoir, which can be quite expensive. But we do have the Walcott Reservoir, which was originally intended to fill Shuttle Meadow, but back in the 60s, we created a new pipeline to feed the Wassel Reservoir from that. And now we have the addition of the Patton Brook well, but again, limited use of. I can take the Patton Brook well and pump it to Shuttle Meadow and get 1 million gallons a day. But if I pump it to Wassel, I get less than half of that. It needs to be worked on significantly. This is our treatment scheme. I'm sorry. Our new treatment plant was built in 2004, was put online. I came in 2001 to help oversee the construction of it and make sure that the chemistry would work properly. We can take water directly into this plant from Wigville if we need to, but being a small reservoir with such a large watershed, the water quality, the term that we use in the water treatment business is flashy. It's on a nice steady day without any rain, the water quality is good, but if we start getting rain out there and being such a large watershed, the water quality drops significantly. We can also take our water directly by gravity from the Wassel Reservoir, and we pump it from the Shuttle Meadow Reservoir into this building. The new plant at the time was the state of the art. Incredible design. This plant has amazing water quality. We use ozone as our primary disinfection. We used, at the time, what was known as a new coagulant, polyaluminum chloride, and we have these 3 plate settlers, which was able to, by installing this equipment in our settling system, we were able to shrink down the footprint of this plant incredibly. It also tremendous boon to our water quality. We also use a new type of filtration medium. We use granulator activated carbon, GAC. And because we use ozone, we get a small layer of biologically active carbon on the top of those, which also helps remove organic material. And finally, our final process is pretty simple. We add lime to control corrosion. We add fluoride because it's mandated by the state. Any town in the state of Connecticut that serves over 20,000 is supposed to add fluoride. And then we use sodium hypochlorite, which is chlorine, to maintain that our distribution system is free from any sort of contamination by bacteria or viruses or any protozoa. This is a basic scheme of our plant. We have the 3 sources that come in. We hit it with ozone, and then we clarify the water by adding that coagulant. It goes through our flocculation, then through our plate setters, and then it gets filtered out. And on the way out, we hit it with lime, with fluoride, sodium hypochlorite. We have the ability to add carbon dioxide. Because we went into some issues when the plant was put on, we've eliminated that, and we use a high pH scheme to control our corrosion. This is an ozone generator. Very expensive piece of equipment, but it gives us some great ability at this treatment plant. Not only does it kill bacteria, giardia, and other protozoa, it controls cryptosporidium. Cryptosporidium in the 1980s was responsible for the Milwaukee outbreak, where 400,000 people got sick. Almost the entire population of Milwaukee got sick because of cryptosporidium. And with that occurring, there was a whole new set of laws that came through. One of the other benefits of ozone is it oxidizes metal. It's oxygen. It's basically oxygen. And it also helps in our turbidity removal, and it does bleach out taste and odor compounds and color compounds. So it's a really interesting and powerful chemical that we use. Again, our GAC is a very interesting process. We use this media, and this media is fantastic because it can actually absorb organic pollutants from the water as the water is being filtered. This is a typical scheme of one of our filters, but these are the tiny granules of media in there, and all these fissures and cracks act as places to attract contaminants. 1 pound of activated carbon basically has about 200 miles of surface area, which we can attract all these organic contaminants. They help remove VOCs, which are volatile organics, mostly like gasoline, toluene, things of that nature. It also removes SOCs, which are synthetic organics, pesticides and herbicides. So this is a really important step in our process. It also removes taste and odor compounds, which are also organic for the most part. We use a liquid. One of the changes that we went to when we had the new plant put online, we went from a gaseous chlorine system where we had these massive 2-ton cylinders of chlorine gas, which were quite dangerous. If we had a leak with one of those, we could have big problems. So we switched over to a liquid system, liquid bleach. It's safer to use, it's easy to use, and it provides a really good disinfectant. The other thing that we changed, we went from aluminum sulfate to polyaluminum chloride, which was at the time a new type of coagulant. Uses a lot less alkalinity, so we don't have to add chemicals at the front of the process. It works over a much greater pH range. It also works well in cold temperatures. One of the biggest problems that we have with working with aluminum sulfate was in the winter. We couldn't get a good flock formed, but we now can avoid that. And we don't need to add any other sort of polymers to help with the process. Our final steps are we add lime. And what we're trying to do here, because of our aging infrastructure, is we're trying to produce this coating here. This is much more exaggerating than what we actually do. But what we do is we build a scale between the pipe and the water. And we build a protective barrier to keep the water as safe as possible from the actual metals in the pipes. And that could be anything from iron, galvanized steel, lead. So we're trying to separate that. We do that by adding lime, which raises our pH. And there are some studies out there that say high pH water is very good for your health. I've actually seen bottles of high pH water being sold for $5 a bottle. So Britain's doing pretty well. We also add fluoride. Again, it's required by the state of Connecticut. And seasonally, when we have high levels of manganese in our reservoirs, we have to use potassium permanganate. And that just removes iron and manganese from the water. So basically, a simple process when you look at it overall, but the devil's in the details. It is quite complicated to operate. This is our distribution system. As you can see over here and in this map, we have different areas of concern. We have 274 miles of water main. I didn't know it was that high when I first got these information. We have over 2,000 hydrants. The pipes in our systems range from 30 inches to 4 inches. Some of our pipes go back to the original 1860 pipes. You know, it's great to have this stuff, and it's again a marvel that they're still there, and some great engineering work was done, but you just built a very new state-of-the-art treatment plant, and you're putting in an 150-year-old pipe. So there's some issues. We also have 3 water storage tanks, which were all built since I've been here. We have 4 pump stations, which we're working on, and these are just in the distribution system to service our high service area, which is red areas down here, and then we have our low service area, and you can see them better here. We have our high service area, which is served by the Corbin Avenue pump station, and I'll go into the details there. And then we have a smaller Steel Street area. Right now, we're serving approximately 85,000 people. Even though the population in New Britain is less, we do serve Kensington, Berlin, and we actually supply some water as far as Bristol, Connecticut. Okay? And we have approximately 18,000. It's more like 17,700 customers, service connections. Okay. Like I said, this plant was ideally, the engineering behind this plant, or the location of this plant, was fantastic because approximately 2/3 of the city can be fed by gravity. No pumping to those areas, just flows naturally from the tank that's outside of here to those areas. Again, great engineering. We have the high service area, which is fed by the Elam Street elevated storage tank and 3 pump stations. And then we have the Steel Street high service area fed by 1 small pump station. We also have numerous valves in our system. And those valves have to be maintained. We have to open them and close them. Some of them are throttled to connect between the two service areas. And if we do have any issues during a main break, we can close and shut these to provide ways of alternative ways of providing water. Our mains basically are distribution and transmission. Difference is transmission just moves large quantities of water from one part of town to another, while the distribution system actually connects to people's homes. This was our clear well, and it's the one that's right outside of our treatment plant. Its capacity is 4.25 million gallons. This is a really important step before the water gets into the distribution system. This is our contact time. This is where we add our chlorine and allows the water and the chlorine to mix and provide the security that we need to make sure that that water is disinfected. And we also maintain a chlorine residual that goes into the distribution system and keeps it free from bacteria and viruses. The design is very interesting because if that ever went down, we'd have a problem. So it's a tank within a tank. So we can isolate one half of the tank from the other, maintain one while keeping the other one in service. This is the Elam Street Low Service Tank. This was just put online in 2015. It provides 2 million gallons of capacity. It was reduced from its original tank that was there was 4 million gallons, but we have issues with water age. We wanted the water to be as fresh as possible, and when water gets old, and you have some organics in there, which is natural, and you mix it with chlorine, we get a chemical that's very problematic. It's called a disinfection byproduct. And by reducing the amount of water age, we lower the potential of that forming. It also provides fire protection to that section of town. And one of the things that we added there, well, we added some sensors there, which monitors our pH and chlorine levels. So if there is a problem, we can get a signal back and we know what's going on. One of the great things about modern electronics. Another tank that we replaced, and this was about 2008, was the Elam Street elevated serve tank. We had the second oldest standpipe in the country, and it was a marvel again. It was built in 1939. It was amazing when we tried to tear it down. It did not want to go down. We beat it with a wrecking ball until it finally gave way. But it was limited in capacity. It was a standpipe as opposed to elevated storage. Imagine just a pipe about this size, just full of water. And it only provided pressure as high as the water rose. By elevating, putting it all on elevated storage, now we have 1 million gallons of water all at the same pressure at a higher elevation. Water-related pressure is dependent on the elevation where it's coming from. It also gave us an opportunity to help the other parts of the city. We put a communications antenna up there, and we have better radio communication throughout the city. In 2015, we also modernized our Corbin Avenue pump station. Its pumping capacity is over 4 million gallons a day. We modernized it. We put variable frequency drives, which basically allow the pumps to run at varying speeds as opposed to either being on and full on or and on off. We included a new generator, so if something happens, we know we've been having a lot of storms recently, we have a generator that can operate that plant and provide water throughout the system. Again, we added those variable frequency drives, which allows much more efficiency. We automated the plant. We have SCADA there now, which is supervisory control and data acquisition. Basically, we can operate that pump station from this building or any other one of our facilities that has SCADA capabilities. And recently, we have just finished completing all the new pumps that were in there. So we're constantly moving forward. We have another pump station which acts as a redundancy, but it provides backup. It's completely underground. I believe it's in Pulaski Park. And this is it, an underground vault, and we have 2 inline pumps, which basically could pump 1 million gallons a day through that, and that connects to our high service area. And that will be over here. And that connects and provides water to that. And again, constant speed. Something should be there constantly because it's much cheaper to run at one speed than it is to vary. But not as overall efficient. Again, it provides water to the high service area, and it can fill the tank, which is quite good. And again, it allows for that redundancy in operation, so if something ever had to be done to Carbon Avenue, we still have a backup to provide water to the high service area. And finally, we have one of our oldest pump stations. This was built in the 1930s, and what it actually did was connect the old high service and low service tanks. So we could take water from the tank, and from the low service tank, and pump it into the high service tank. Limited capacity, about 500 gallons per minute. Again, it's 2 constant speed pumps. We did some work in upgrading the monitoring systems up there, and we also put a connection to a generator. We could bring a portable generator out there and operate this during storm situations. Again, it is used to provide water to the high service area, but it really connects the low service tank to the high service tank. We also have a small area, Steel Street Pump Station, which provides water for this small section of town right here. We did an inspection a couple of years ago, thanks to Lori. She put out Lori Matthews from the Department of Public Health, put out a letter to inspect our pressure tanks. And when we looked at it, we realized that it was about to go. So we've changed the operation scheme there, and we have a constant speed pump station. We've gotten rid of the tank, and we're in the process. We've actually just got the design plans to make this much more efficient, and we'll be doing that in the real near future. It's going to provide a lot better service for the area. One of the issues that we had here was because it had a tank, the pressure would rise and drop depending on the water level in that tank. And it was a small tank, only had about 2,000 gallons of it, but a lot of pressure because of the air that was required to push the water out. Sorry, let me get back here. Did I go back here? Okay. Our distribution crews, as you can see, work under some of the worst conditions possible. Usually we get a main break, it's cold, there's tons of water in there, and you had to send the guys in there. As you can see, this is a main break. Our guys are covered in snow. But the water crew does a lot of different things. We install water mains. We replace hydrants. We do water services, cuts and repairs. We pressure test throughout the system, usually required by builders. We disinfect water mains. We help contractors. We also provide a lot of our services to neighboring towns like Berlin. We respond to emergency, and we do our annual maintenance. And annual maintenance is something that has to be done. You can't stop that. That includes flushing our distribution system. We do maintaining our hydrants. We flush them, we grease them, we paint them, we pump them out. We do valve maintenance. We're constantly opening, checking these, and closing these valves to make sure they're operational. We clean them, we locate them. Sometimes we'll find a valve that nobody knew about, a 100-year-old valve. This is an example of what Mark was talking about. By combining our departments, we got a lot better response. This was the Chestnut water main break about a month ago, a little bit more than a month ago. You can see the crater that it left. We lost 1 million gallons in 45 minutes. It was incredible. We left the police department without water. One of the tragedies was we had to close the dialysis center because it flooded. It was an 8-inch distribution main that was connected right out our 16-inch transmission main, so the water there was flowing out incredibly. It was a 2-day repair, and this is what's amazing. We did that all in-house with our own staff, our own people. We did it for a cost of $25,000. This job, if we would have put it out, would have been probably 8 times as much. That pipe was a 1975 pipe. We were able to put the road back in service in less than 2 days. A really good point here. This is our crew laying out the new pavement, as you can see. Again, all in-house staff. Very proud moment in my life here. You know, I can't say enough about what my crew did, what Dave Gominas, raise your hand, Dave. Dave was the leader on that. We did something that was incredibly good. Thank you, Dave. This is another job that we were doing. When we connected the Patton Brook well, it hadn't been used for years. The hydraulics of it were unknown to us, and when we connected it, we were running tests on it, and then we noticed that we had a main break in Southington. Could have been an air bubble that had been there for many years, but again, it was a 30-inch transmission line. Again, Dave and his crew. Largest job we've ever done, largest pipe installation new. Again, in-house. Took us a little longer, 4 days. It was out of town, we had to get permits, do some things. But we did it, again, all in-house. We got some great help from the MDC, they loaned us some equipment. And again, cost of repair was about $20,000. If we would have gone out to a contractor, probably 5 times that much. Again, this pipe was dated to 1892. The reason we found that out, when we looked at the original pipe, it said 1892. It was forged in 1892. Amazing. Lasted 100 years. Well, one of the most important parts of the distribution system is the meter system. This is our cash box. This is how we make our money. This is what also led me to do some things that we'll talk about in a few minutes. But meters are really important, and we have a great meter crew. This is a typical meter installation in most of your homes. We have our main, and we connect it to your home, and we have 2 ways of stopping the water to your house. We have a corporation stop, which is right in the main, and then we have a curb stop. And then the water goes through a meter and goes into your home. One of the things that we've done as an initiative in the last 20 years is we've almost got rid of all our hand-read meters, and we do it by radio frequency. Meter crew does a lot of different things, meter replacements, high bill investigations. They do all the markouts for other utilities, call before you dig, and we do customer service investigations where we're looking for service leaks. Which again, when we noticed the numbers of water, the amount of water that we were producing from the treatment plant and how much we were billing through our meter system, we realized that we had a problem. So I ordered a water audit, and we found out that we had 1.4 million gallons a day leaking into the system. Again, that's related to our ancient distribution system. 1.4 million gallons a day, close to 500 million gallons of water being wasted a year. Okay, right now we've done a lot of the work, but when we did the work, we were able to identify that a lot of these problems were from service connections, which is the responsibility of the homeowner. We had water main breaks, valve leaks, and hydrant leaks, which is our responsibility, and we're taking care of that. But we found over 110 leaks throughout the entire system. To date, we've repaired about 500,000 gallons of those leaks. Currently, we're in the process of addressing the leaks with private service landowners, the homeowners, and we've been telling people for years to buy the water service line insurance. If they have that, that'll cover the cost of this. If not, it's going to be anywhere between $3,000 or $5,000 per person, which is problematic, and we're trying to come up with a solution to help our residents. Again, the service insurance is really important. People should buy that. It's not only available for water, it's also available for the sewer system, because sewer laterals are also a problem. Our future, we're moving forward. When we talked about the Whitesbridge well field, we're in the middle of conducting a study right now to see if we can actually use that as a potable water source. If something were ever to happen to this plant, we would be in trouble. There's not a lot of water coming in from the MDC that could do it. Plus, that chemistry is completely different from us. And as I got into the weeds about Flint, Michigan, I found that the biggest problem that Flint had was a change in water chemistry. So if we have our own backup source, which we can control the chemistry, we're going to be a lot better. And that well field has the capability of giving us over 6 million gallons of water a day. We're looking at automating our treatment plant. Believe it or not, this plant is 12 years old, but our computer system is obsolete. And we have a hard time getting parts, so upgrading our automation. We're going to make it so that our plant can be operated remotely from my home, my operator, We're looking at the security measures, which is really the most important part of it. We're upgrading our pump stations. We're doing our raw water pump station out in Whitesbridge. We're looking at that. We're looking at our West Canal, which is an old structure that needs to be really taken care of. We're looking at our Whitesbridge surface supply. We are doing some distribution system replacements. We're trying to get rid of some of our dead ends. They're basically pipes that basically go into a neighborhood and die there. That becomes problematic because it gives us stagnant water. If we're able to loop that, we'll get much fresher water throughout the system. We are continuing to continually investing in our water system. Water leak audits will be commonplace. We're planning to do these every 5 years. One of the best things that we've done is we cross-trained our staff. So they're not only working in the water department or the sewer department, they work with the caretakers, they work with the public works department. And all this is because water is essential for human existence. You know, water is life. Without water, you're not going to have life. This is some of the projects that we're working on right now. As I mentioned earlier, we have dams, 8 high hazard dams. We're looking at doing some more work to our Woodville Dam. This is it is a dam, but it's because it doesn't have a structure, it's called a dike. And we're doing repairs on those. We just got them inspected. One of the things that we've had, this is our SCADA system. And again, if you look at this, this is a screen that my own people built. And it tells you every step of the treatment process from the plant. The water coming in, how it's being treated with ozone, how it's being mixed with the chemicals when it's settling out, coming through our filters, and the chemicals that are going out. We need to update this. And we're in the process of doing that. This is one of the things that has been mandated by the Connecticut Department of Environmental Protection and Energy. It's a dam inundation study. The old standard was a 100-year storm, but because storms have become much more frequent and much more violent, the standard was raised to a 500-year storm. If this Shuttle Meadow Dam were to break, this entire area would be flooded. So we had to perform this study, and this cost us $45,000 for one of these dams. We have 8 of them. And what we had to do was identify all the entire path and be able to notify everybody in its path if something were to happen. Again, this is the worst case scenario, and we do maintain our dams and we put a lot of money into it. But again, we had to make these plans. And this is, again, the future of our system. This is the Whitesbridge well field. This was provided to me by CEI, the consultant that we're working on. And this is what it is now. That pump station was built in 1923. It has a pond. It also has a canal in the middle of it, which connects 2 small brooks, the Pokeville Brook and the Coppermine Brook. And if you could see along the canal, we have 32 wells. Very shallow wells, a vacuum suction system that goes back to the 1920s. We want to modernize this. We want to put new wells out there, make sure that it's safe, have this as our backup. It would also help us in our sales to Bristol. One of the crazy things that we do is we take water from Woodville, bring it over here to New Britain, treat it, put it in a pipeline, and send it back to Bristol. If we are able to build this, we could sell it directly from there to Bristol. Much more efficient. Also gives us the capability, if something were to happen to this plant, to survive. And survive with our own water chemistry so we wouldn't destroy our own distribution system. Again, this is a nice view. And there are 2 well fields there. Again, this is the lower well field where we have all these lines. And then we have an upper well field, which has tremendous potential. The water up there can be incredible. I've been told that the quantities up there can be quite substantial. And this again is an overview, and we're going to cross this road, and we're going to go see our upper well field. Show you a quick picture of that. And you can see the Coppermine Brook. And this was the one that was controversial the last couple of years. And again, this is our upper well field. We have a small pump station. Then we have 2 fields where we have 3 wells in each one. And we want to build at least 1 well in each one of these. And again, this is property we own. It's a great resource. We want to just modernize up there. And again, I cannot stress how important this is for our future as a water department. It will also give us the ability to grow if we need to. And these are the well fields out here. Fantastic place. Okay, the other project that we're doing, again, is eliminating some of those dead ends in our system. We're going to loop these to enhance the water quality. And our first project that we're planning to do this is by Batterson Park. And we're probably going to do this in-house, again, with Dave's staff. Again, we're trying to keep work in-house and doing it on our own. It's better for us, so we can respond to emergencies, get our people trained, and it's going to be cheaper and more efficient for the city. Finally, I wanted to talk about our rates. We're doing all this, and these are the rates of towns around us. I want to thank Barbara Yazowski. She helped me out with this. She got all the information here. And you could see what a typical charge would be for the customers of these different water utilities. This would be a 5/8 meter using 2,000 cubic feet in 6 months. You can see New Britain is $82.42, while you can see most of these are well over $100. The only one that's cheaper than us, and I don't know how they do it, is Manchester. Even though Manchester sells their water for more than we do, we sell our water at $2.92 per cubic feet. They sell their water at $3.28. I believe their meter charge is probably much less than ours. But all this, we're doing this, all this work, we've been responding, we've built a new treatment plant. We've done all this while still maintaining one of the lowest rates in the state of Connecticut. On that note, my presentation's done, and I think we're going to take a break. If anybody's interested in a quick tour, I can take them through some of the basic components of the treatment plant.
How about some questions?
We're going to save those until after the second part of the presentation.
Okay? All right, and like I said, let's take a break, and we'll have coffee, refreshments on that.
Part 2. Sanitary and storm sewer systems. The fun part. This part of the presentation, Director Moriarty is going to talk about our sanitary and storm sewer systems, talking about our sewer collection, our general maintenance, our fog programs, fats, oils, and greases, our infiltration and inflow programs, and then we'll talk about the CMOM order. Those of you who read the Herald, Skylar, thank you for being here. You'll see me commenting quite often about the CMOM order, capacity management, operations, and maintenance. And that has taken a big toll on our operations, which Mark will get into. And then we'll talk a little bit about the stormwater sewer collection system, just a brief overview of how that works. And then Michelle Ryan is here from the Mattabasset District to talk about where all that stuff goes when it goes down the pipes. Again, Mark, I will turn it over to you.
Thank you, Mayor. This part of the program is definitely a little less glamorous, and we don't own a treatment plant. The city's responsibility on this part is really the collection system for sanitary sewer and also for storm. Have a couple maps here. This one actually shows the sewer system. We have 179 miles of pipe, 3,600 manholes. Impressive thing about the system, and it's something that Ray hit on his system also. The system is almost entirely gravity fed. So New Britain's a hilly city. Everywhere you go, you're pretty much going up or down. When New Britain's sewer system, really this map shows it well. Everything in the 3 major sub areas flows to 3 different trunk lines. One through the central part of the city, one through the southern part of the city. They all merge together at the very southeast side of the city, and they travel 9.5 miles down to the Mattabasset treatment plant. They do this all by gravity. What you don't want to do with any utility is have to pump things. Gravity working on your side there's no energy cost associated with gravity. So That's a great thing about our system. We have one pump station. Let's say a little bit more about our system. We do, our northern trunk sewer travels through a brief portion in Newington, pick up a little bit of Kensington and just a couple properties in Farmington. Let's say, besides that, it is an old system. About 38% of our pipes in the ground are 75 years or older. The thing about that is when you're buying a product, products always have a life, okay? And a lot of times they talk about things were done better in the old days. One thing that wasn't done better in the old days is sewer pipes weren't better in the old days. So a sewer pipe that was put in the ground over 75 years ago probably has a design life initially of maybe 25 years. So it's been in the ground now for over 75 years. And that's why when I get into some of these other problems that we have, that's a lot of the reason. One of the big problems you face with sewer systems is tree root damage. This is some just various examples of it, but obviously roots want to find water. They need a source of water, and sewer pipes make for a good source of water. Unfortunately, when they get into a sewer system, they cause trouble. I mean, they actually can crush a sewer line. They create a great place for debris to collect and then block a sewer line. Like in this one, they just constantly do. And then unfortunately, the sewers, when you have roots in it, it works in combination. Okay, this is our safety valve plug. And I was gonna do this on both the water and sewer. I just ran out of time. But basically, even more so on the sewer, though, sewer lateral insurance is pretty inexpensive. It's less than $100, and a sewer or a water repair could cost you $3,000 to $5,000. And especially in the sewers, I mean, this is a commonplace occurrence that roots get into your sewer system, your sewer lateral, which you're responsible for, and they damage it. They could break it. If you do have roots in your system, it's easy to clog behind these roots that occur. So the sewer lateral insurance is very important. That's all I'm going to say on that. It's not really an advertisement. It's just like I think it's a smart suggestion for you. The other problem with sewers, and this isn't, like the mayor said, this isn't the glamorous part of our presentation by any means. But the roots, they not only cause damage themselves and could block a sewer line, but then fats, oils, and grease gets into, say if you have a restaurant, even a homeowner. We've had big problems with just homeowners. The roots in a sewer pipe, then combined with fats, oil, and grease, the roots give an opportunity for these to collect, to grab onto the fats, oils, and grease, to grab onto the tree roots. And it causes problems. I mean, it's really just cooking greases. We have a substantial fog program in place. The fog program that we do have in place, it's primarily just restaurants related and facilities that have commercial kitchens. What we do is it's a joint effort between the Public Works Department and the Health Department. We have about 250 food establishments, mostly restaurants. It's a deep and EPA required program, but it's also just like, this is one of our big problems for sewer backups. When you see sewer backups that happen, a lot of times this is it. For both those issues, the tree roots and the fats, oils, and greases, we do probably the most common thing we do with our sewer maintenance is jet rotting our sewer lines. So we go in there and we clear out the tree roots, or we clear out the fats, oils, and greases that accumulate. There's also some areas where you just have a sewer line that's not really at a very sharp slope, or we even have a couple little dips, so we also have to jet rod in those areas. But this maintenance goes on all the time, and depending upon the severity, if we know this is an area that's very prone to tree root damage, or we have fog issues, we either jet rod quarterly, triannually. In some areas we might have to do a little bit. Tree roots, we also will apply a chemical inhibitor to help with the issues. This is another thing we do. It's really somewhere related between storm and sanitary sewer. Illicit discharge detection and elimination. That's basically, in some cases, you'll find somebody improperly tied a sewer connection to the stormwater system. So then it goes and outlets into a water body. You can kind of see in this slide the discoloration of water from the storm system going into a stream. Let's see, there's a lot of things that we have to do associated with this. We have to do wet water testing, dry water testing. Obviously, if you have flow in a storm sewer when it hasn't rained in a while, it's probably an indicator that there's something else connected to it that shouldn't be connected to it. The biggest issue, though, that we deal with, and this is something that Michelle Ryan's going to also talk about, is infiltration and inflow. It's a major environmental issue. I'm going to get to some of that, but it's also a financial issue. The big thing about I&I, this is what it is. We have sewer lines that go down to Mattabesset treatment plant. We have sewage flows of probably about 6 million gallons a day that come from just our actual sewage use. Well, we have about another $6 million gallons a day that actually just infiltrates into the sewer lines, both from laterals and mains. And that's twice what, like, as much as we produce in sewage, we also have clean water that gets routed down to Mattabesset treatment plant that then needs to go through their plant and be treated unnecessarily. Environmentally, that's a big problem, and I'm going to get more into that. So will Michelle. Fiscally, it's a problem for us also because we're billed based on our sewage flows. I mean, how much sewage we contribute to the plant, our percentage of the flows is based on what our allotment of our annual bill is, and half of that is clean water. Infiltration, the most common thing that people really think about is this. It just basically, especially when you have older sewer lines like we talk about, just clean water getting through an old joint. This is an indicator that you might see about and basically, so we have a sewer line. There's a massive storm. So much water, clean water, gets into our sewer line during a storm event, like some of these really high peak storm events, that actually pops the top off of a manhole. It happens more and more regularly, unfortunately, with some of the weather trends that we're in. Well, this is actually, it's estimated between 5 and 6, so it's a little inconsistent with one of my other slides. I got another slide. I'll probably talk to this a little bit more about how infiltration gets into. But this is the thing. Out of infiltration and inflow, infiltration is the bigger of the two components. Getting into the joints, getting into the pipes. Actually, that is estimated at 5 million gallons per day. And inflow is a smaller component, but it's still 1 million gallons a day. And that's more when people have like your roof leaders or things like that connected into the sewer system. I'll kind of show you, not exactly how hard this is to see from back there, but what this graphic shows is that you have a storm line going here that would collect just basic rainwater, and you have a sewer line here that's that's supposed to just catch sanitary sewer. So coming from the house where you have your roof vent and that's coming into the sanitary sewer, that's an example of inflow. Another example of inflow, say if you had a catch basin, which we don't, but catching surface water and getting it into the sanitary sewer line. See a tree with tree roots. Tree roots breaking into the sanitary sewer line, causing cracks where water gets in. That's infiltration. It just cracks in the sewer or in the sewer main, just lead to infiltration. At any rate, it's like between both of these things, we're doing a massive amount of work to reduce these things. It's one of the biggest things we do capital investment wise, and it's something we have to do. Getting into some of this, and this is something Michelle's going to talk about a lot more, and probably a little more in depth than me. But So our average flow, 24 for 2018, which was up because it was such a wet year, 12.24 million gallons per day, 62.7% of Mattabassett's flow for last year. So, based on that, coming up into fiscal year 20, which starts July 19th, this is what our assessment is from Mattabasset going into next year, 55% of our budget. So anyways, 12.24, that's our average. And a peak flow from last year, and this is from Mattabassett's meter, which I think tops out about 50. So it could have been greater, but tops out at 50. 45.8. So one day we had 45.8, almost 50 million gallons from New Britain's flow getting routed to Mattabasset District Treatment Plant. So Mattabasset Treatment Plant has two different capabilities. If you just go through with primary treatment, which it really doesn't chemically treat, it doesn't actually take and make the water safe to go back into a water body or environmentally safe. At that point, they can remove solids, greases, oils. They go up to 110. So they have a fair amount of treatment for that. But actual treatment for treating the water so it's safe to go into a water body, they only go up to 55 million gallons a day. So during this one storm, this one peak event, we basically alone out of the Mattabasset communities, which we're not the only Mattabasset community, we almost exceeded that on our own. So this is what happens with infiltration and inflow. That's the big thing about it, is that so we all have New England in general, it's just older infrastructure. Britain's probably a little older than some of the other communities in Mattabasset, but all of us put our pipes in the ground quite a while ago, and we all have infiltration and inflow issues. So basically, something we always work on. And then again, just on the financial side, if we were able to reduce our flows, not only would environmentally, we'd be sending non-polluted water back into the Connecticut River, but if our percentage of the flow came down, so would our costs. Let's see. What we do about it is Seb Pimenta from CEI is back there. He does a lot of this work. He's been doing it with the city forever. Unfortunately, this is a massive effort. We'll be doing this work long after I'm here. It's a continual thing. We have a big system, and this requires a massive investment. We do flow meter testing in the sanitary sewer system. What you do is basically you try to figure out the areas where you have the worst inflow, and then basically, because it's everywhere, you want to at least spend your money as wisely as possible and figure out where you get the most bang for your buck on your investment. So a couple of years ago, for the second time, we did a complete study of this entire city and looked at our I&I issues, and now we're in the project phase again of implementing projects to reduce I&I. Just basically a slide that shows some of the I&I. What you do for infiltration and flow elimination is basically you line the sewer pipes. Basically put another pipe inside that pipe. Great thing about it is it doesn't just make the water tight, but also gives you a structural repair, because the pipes that are in the ground are really not, by decades outlived their useful life. So this actually puts a strong pipe, a new pipe in the ground. In addition to the other issues of improving the I&I, cured in place sewer lining is the process that we use. Just completed a large project in 2018, $2.5 million project. When the pipe gets inserted, it's actually a soft pipe that then gets inserted into the sewer line and gets cured in place to have a hard surface. What we're doing now, and because the city's been doing I&I work for a long time. We did a lot of work in the early 2000s, put about $12 million of work over initial port, and we see minimal reduction of our actual I&I, okay? Because at that point in time, most of our work was just in the mains. And that was basically what we had to do at that point in time. There wasn't the processes necessarily in place to chase down some of the I&I. So what we're looking at doing now is a more comprehensive process. And the big thing that we didn't do is just like when Ray was looking at his water audit and half of the leak came into service laterals, same thing on the sewer side. He had 1.5 million gallons of leakage. We found only 400,000 of those actually existed in the water main. On this side, when we're lining the mains, which we did in the early 2000s, well, half of the infiltration to our systems actually come in from the laterals from the houses, like the smaller laterals, and we didn't have the ability at that point in time to really actually line the laterals. So now we're going through projects right now. Sorry about that. Lateral lining is a much bigger portion. Manhole lining we have done. That's something we did do historically. Let's see. We have lined since 2000, 28.15 miles, so about 16% of the system has been lined. We have to go back and do more work on the laterals. Going forth this year, actually C9N1 on this map. So this is one of the areas we worked on in 2018. This is the other one. At this point, we've completed the main work. We have to go back and do the sewer lateral work. And it's a complicated thing. And again, like Ray mentioned, sewer laterals are the responsibility of homeowners, but it's a pretty burdensome thing to put on the homeowners. So we're trying to figure out a way to go and improve these laterals without totally passing the complete cost onto the homeowners. And the way I look at it, because I'm also, as public works director, I'm also involved with downtown projects. If we do a capital project on the street, we'll replace sidewalks. By ordinance, sidewalks are a person's responsibility. But when we're doing a capital project, we typically improve those too. So I kind of correlate it to this. We're doing major capital investments in some of these areas and do work that historically has been the responsibility of a homeowner. But we would be doing this work regardless. I mean, it's the right thing to do. There's a cost benefit, there's environmental benefit, but we're also under consent order to do this work. And let's say when Mattabesset treatment plant did their expansion and they're $100 million, is that still the number? 110, $100 million upgrades, and part of that was federally funded. So part of the federal funding meant that EPA came and looked in all the Mattabesset communities and looked at our sewer systems, looked at our I&I issues, looked how we're managing our sewer system, and all of us were fortunate enough to get this extra added benefit of absorbing the cost of a $110 million plant, which it was the right thing to do, but still. Of having a CMOM order placed on us by EPA. So related to that, we negotiated our CMOM order. All the communities had CMOM orders placed against them. Our portion is that we're required to do a $20 million investment into our sewer system over the next 10 years. Good thing that we're doing with that, I mean, is that we're putting it into the actual budget. So we're not borrowing on it, we're trying to pay for it as we go. We're not trying to put the city in further debt with these operations, and we've been able to accomplish that. As far as our sewer rates, similar to Ray, it's too bad when Ray was showing the water rates, it was hard to see. I was sitting pretty close, and you really couldn't appreciate it, but the water rates are about half of what a lot of MGC communities, other communities. You probably couldn't see that from even the middle rows and the back row. And the sewer side isn't quite like that, but we're still, despite we're doing all this work, despite we did do the largest community that's helping fund a $110 million treatment plant upgrade, or that's money that we're putting into our sewer system. Rate-wise, MDC's got 8 towns, very similar towns, East Hartford, Meriden, similar sized town. Manchester, who is quite a bit lower than us on the water side, is actually more expensive on, or actually not that much less than us on the water side, but they were less than us. They're more expensive than us on the sewer side. So at $4.30 for 100 cubic feet, we're still competitive and actually on the lower side even on sewer. Moving forward, kind of hit on all of it, but actually this I&I issue we have to address with our sewer system, that's going to be the primary thing that we're working on for years to come. It's a large city. We did 28 miles, where that's a dent, but we have a long way to go. But you know, we take it seriously, and we're serious about doing this our EPA compliance requirements. I'm going to hit very briefly on stormwater and then turn it over to Michelle Ryan. Our storm sewer, this map kind of shows it. It's, let's say, our stormwater when it falls, when it rains, it goes into 5 different basins, 5 different water bodies in the city, and the numbers on this map are indicators of the 123 different stormwater systems and the 123 different outlets into the stormwater systems. When I talked about illicit discharge before, and you're tracking down a sewer issue, that might be a sewer connection that's into the storm system. When you're tracking down those illegal connections where sewer got into the storm system and there's like cloudy water coming in, well, to actually determine where those are, there's 123 different outfalls we have to investigate to see where those could be. A lot of those are in the middle of the woods and, like, you know, brush. It's a difficult task actually just to do that. 154 miles of stormwater pipe, almost 5,000 catch basins around the city that we're charged with cleaning, almost 3,000 manholes. There's 55 miles of streams and brooks. The big thing about catch basins we're seeing lately, just to hit on one thing, with all the flooding that occurs lately, when there's a storm coming, we're like, well, how come you guys weren't out there cleaning off the grates, okay? And we do. We have priority grates that we clean in areas where we know are prone to flooding. But there's almost 5,000 catch basins around the city. We're never going to be able to clear even a small part. We clean about 100 that we know are really prone to flooding when there's a storm. We go out there, and we did it last week when you had rain following the icing event. We were out there with plow trucks cleaning off the snow and ice over those catch basins. Let's say a lot of maintenance work associated with the storm system. A lot of it is required just for cleaning out the storm system. You'll see our trucks out there sucking out the material from catch basins. We're required to do that actually as part of Connecticut Deep's MS4 permit. But also, we don't see a lot of material in the storm sewers like we used to. In 2008, we changed from salt or sand operations to salt operations for when we're doing our snow. We don't put sand out unless it's really needed because it's really cold and it's below the temperature where salt actually works. So one of the added benefits of not using sand anymore is catch basins used to all be filled with sand. So a lot of times we go back to clean catch basins right now, even if we haven't been there in over a couple of years, still don't see that much debris in them. This is something that we are dealing. Actually, this picture just a regular activity. It's probably preparation of when we do our paving list every year. We go through, try and change out as many catch basin stops to the newer style catch basin stop. They're more efficient in capturing stormwater. They do a better job. Something that we're seeing more and more though lately. This year is probably one of the worst years, one of the wettest years on record, and running into flooding issues. important thing about the stormwater system, and I think Ray talked a little bit about design storms. So our stormwater system is designed for a 10-year storm, okay? That's common. Connecticut Department of Transportation's stormwater system is also designed for 10-year storms. Now, that is sufficient, you would think, for most cases, but now we're seeing more and more storms that exceed this. We're seeing 100-year storms that are happening very frequently. So even by design, our systems that were designed for a 10-year storm can't now accommodate storms that are happening pretty regularly. And some of the like older cities like New Britain, that basically a lot of the building happened prior to people thinking about some of these things. They're built out prior to people thinking about the amount of flooding or the amount of impervious area that was getting contributed. So when it rains, everything flows. It flows really quickly. You get a situation like this, and our guys are out there trying to clear off a catch basin top. Obviously, when water's running, it runs to that catch basin top. Debris accumulates on top of it. It clogs. We got to go out there and clean. Last week, I was on my phone with one of my guys on Pond View. That's exactly what he was doing. Between the snow melt and the rain, the 3 inches of rain that happened, he was just keeping that catch basin clear so the area would drain down. It's happening all too frequently. Let's say this actually, Ray hit it, and this kind of speaks to both points. This was the West Canal last week. It's not a stormwater. I mean, it's a watershed area, really. While the West Canal does capture water, it's really what we use to take those outer reservoirs and outlet them to feed Shuttle Meadow. So we've had it turned off for quite a while. We're not feeding anything to Shuttle Meadow. It's been at 100%. So earlier that day, the West Canal, before the snow melt, is basically dry. So over the course of a very short amount of time, West Canal is basically overtopping, and this is the bank that goes down behind some residential properties. That's one of the projects we have to work on. But when I'm talking about the stormwater system and just our flooding responsibilities, this is just a text that's going between me and Ray and our chief caretaker. And basically, the last line of it says a lot. We went through approximately 400 sandbags. I mean, we're sandbagging the edge of this canal to prevent water from going down the hill and on these properties. We've been out 3 or 4 times in the last year sandbagging. In my previous 24 years, we've done this maybe a half dozen times. Crazy. This is just what's happening with us. This flooding, it's become a way bigger part of my job over the past year. Who knows? So 2016, like I talked about in the first part of my presentation, we were in the worst drought in 60 years. So who the heck knows what's going to happen? But the weather fluctuations are definitely a big deal. And with that, that's the end of my presentation. I got to just upload Michelle Ryan's presentation on the Mattabassa treatment plant, which will take just a second. I'll keep going. Okay, thank you, everyone.
Hello, everyone. I'm Michelle Ryan. I'm the Mattabassa District Engineer. Arthur Simonian, the Executive Director, couldn't make it today, so I'm stepping in for him. I'm going to give you some information about the Mattabassa District and how the City of New Britain pertains to the district. We are a wastewater treatment facility, and we started with primary treatment in 1968. We built a multiple hearth incinerator as well. Then in 1989, we upgraded to a secondary treatment system, and we also included a fluidized bed incinerator. And in 2012, recently, we did another nitrogen upgrade, and we also included the City of Middletown. Back in 1989, we upgraded at a cost of $30 million, and in 2012, $110 million. One thing I want to point out about these upgrades is that we are mandated by EPA, and regulations that come up, that there are new standards that come up with respect to wastewater treatment. The member towns of Mattabesett include the city of New Britain, Berlin, Middletown, Cromwell, and a portion of MDC and Farmington. And the district, the Mattabesett District Pollution Control Plant is located in Cromwell. The design of the Mattabesett District is basically twofold. We've got primary treatment and secondary treatment. Now, the primary treatment, we can treat up to 35 million gallons per day on average in 110 peak flow. And the secondary, only 55 million gallons per day. So anything that we have during wet weather events, anything beyond 55 million gallons per day is considered a sewage bypass for us and a violation of our discharge permit. This is why it's very important the communities have I&I projects in their member towns. New Britain flows. New Britain accounts for approximately 62% of the community flows, and the reserve capacity for New Britain is 46 NGD peak flow with 22.5 NGD secondary flow. So as you can see, if we can only fit 55 through the secondary, New Britain is actually allocated for 22.5. The rest of it has to be divided by the other member towns. The district's budget, New Britain's contribution makes up 40% of the district's budget, and it also makes up 51% of all the assessments of all the member towns. So in July, we're looking at, for the city of New Britain, at $6.1 million in assessment. So why is wastewater treatment important? Oops, let me just go back here. So it's important because we know that 70% of the Earth's surface is covered by water, but only less than 1% is actually usable, especially for human use. So we know that it's very important for public health and the environment. So what's being done over the many years that we've been treating wastewater according to the requirements of the EPA and the regulator standards? We know that we've eliminated a lot of death and illness, reduced the cholera, hepatitis, and typhoid diseases. So it's a good thing. This picture here shows the final clarifier. By the time we're done with the wastewater treatment and we get to this point, we actually achieve very, very good water quality, as you can see in that picture. However, it does come at a cost. We're constantly making repairs. We're also constantly conforming to new regulations and requirements by EPA and DEP. And it's an ongoing process, as it also is for the city of New Britain here, what we just talked with Mark Moriarty. Okay, the treatment. Here's a picture of the Mattabesett, and I pointed several different processes that take place throughout the plant. We have influent screening, grit removal, primary settling, activated sludge, final clarification. We have disinfection, solids handling, and incineration. So the activated sludge and the final clarification is basically the secondary treatment. And that's where it all takes place on site. In 2012, we did a nitrogen upgrade, and the additional facilities that we put in included odor control, underground storage tank for diesel fuel, emergency generators, and we have a septic and a sludge handling facility. These are pictures of our new incinerator. We put this in 2012. It was a lot of work. It had to meet the newest emission requirements by EPA. Once we installed it, it actually even took several years thereafter to even operate it in a way where we can meet the emission limits. So our operators did a very good job doing that. The equipment includes automated dewatering and sludge feed equipment. We incinerate sludge, septic, and grease in this unit, and once we incinerate the material, we landfill it. We also put in energy efficiency projects that help us reduce the cost of our electrical bill, which is really what drives the wastewater treatment process. We put in 60 kilowatt solar panels. We put in new efficient aeration blowers, waste heat recovery from the fluidized bed incinerator. We're actually taking heat from the incinerator and we're actually heating one of our buildings with it. So it has helped in the cost of the operation. We also have a lot to do with environmental compliance. We have a lot of EPA and Connecticut DEP permits that we're constantly complying with. We have a water discharge permit, an incinerator operating permit. We have a general air permit for all our combustion units. We have a stormwater permit, a landfill operating permit, and we also have regulations we have to comply with respect to underground storage tanks. The Mattabesett District makes up 6 administration staff, 16 operations staff, 9 maintenance staff, and 2 laboratory staff. We also have to comply with worker safety. We have a lot of OSHA requirements that our workers have to comply with, and then we also have environmental health and safety programs that we have to comply with as well. These are a few pictures of our latest construction. We have some tanks that went in. The tanks hold a chemical that help us in the nitrification in our secondary treatment. We have new screens that we put in the primary screening facility. And this other picture here is a stack going in for our incinerator. This is one of pictures that we took when let me see if I can have it. Oh, good. These 2 new tanks went in 2012. And the interesting thing about this picture is that the contractor had to actually build these facilities while maintaining operations at the plant. So that was pretty challenging, but it was, it worked pretty well. So other than that, Mattabessett's been providing water treatment for 50 years, and we hope to do it for another 50. Thank you.
Okay. Mayor's going to come up and say a few words.
I just have to, just some logistics things. If you did not provide your email address today, Kim from the water department is in the back there. Hi, Kim. Please make sure that you provide it to Kim so we can email out to everyone the presentation that was given today. Make sure we get that to everyone. I think Ray is going to take everyone on a tour. And
If there anybody who wants to go.
I know.
Questions?
Yep, we can do that too.
When, after, or now?
Now, but I'm going to. Sure. We don't have to. We can be kind about it, right? Okay. And so if everyone gives their email addresses to Kim, we'll just make sure that we get all the information out to everyone. Thank you.
Okay. Yes, sir.
Well, first of all, I want to thank all of you for doing a good job this morning. I think it was very I learned a lot, and I want to thank you for the good job you're doing for the city. I appreciate it very much as a taxpayer and a homeowner here.
Our pleasure.
I have a couple of questions for you. One, can you tell us what the capital plans are the city has for upgrading the piping system to our home? What's going to happen with the 1892-year points? Where's your head on all that?
Well, we're looking at eliminating dead ends I talked about. We're trying to look at one particular section of 14-inch pipe that's quite long and it's been quite problematic. So we're looking at doing that. And believe it or not, some of the older 1890 stuff is in great shape. It's thick cast iron, but when it goes, it goes. So we're trying to react to those as best as we can. We do have a lot of things going on. Our plans are to keep on studying the system. We're looking at the results of the water audit, trying to identify areas. But as Mark said, most of our problems come from the lateral service lines that go into people's homes. So we're trying to address those issues. The big issue for us is trying to conserve the water. We spend a lot of money in chemicals, but that's nothing compared to the amount of water, the money we have to spend to pump this water to people's homes.
25%?
If not more.
More.
Yeah, that's a lot of money that we're wasting by putting this water to the ground. So we're going to try to get to those first. The long-range issues are to address the aging infrastructure as needed. We may have to also redesign. Some of our pipes may need to get downgraded. Some of them may have to be upgraded. But like I said, we have a lot of other things that we're doing. So our list of priorities are constantly changing, and we're trying to address the fires that come through every day. So we do have about, what was it, $2.5 million for capital projects this year?
Yeah.
So we are putting it in there, but it's limited funds
Second question.
in 3 parts.
Second question is, as you know, I'm a member of the Protect Our Watersheds New Britain.
Yes,
And, we've had some disagreements with.
absolutely. And those were
I'd like
honest.
to know, number one, if you're going to continue working with Tilcon and the same contractor that you hired, Tilcon hired to do some assessments for the city. Is that going to go forward, and is there not an ethical problem here that you have?
There's no more work with Tilcon. This was the only thing that was done. Actually, we weren't working with Tilcon on that. We were working with Leonard Engineering, and they were taking off the city engineering list. So that's, you
So are
know.
you going to stay with Leonard?
No, they're finishing up the water supply plan, which was put on before this whole thing. But that's about it for right now. We have no real plans to work with Tilcon other than
I don't know
that.
if you can answer this question. Are you still going to, is Tilcon still going to try to take the watershed down the road?
Not to my knowledge, I think that question is over and resolved, that problem is over and resolved. I don't see us going anywhere further with that, Yes,
That's all
Paul.
I have to say. Thank you.
Sir.
Oh, Bill?
Two questions. One, since the greatest use in the home is toilets, and
Yes.
consumption of water, has the city thought about offering incentives for people to replace and install more water-efficient toilets? And the second question is, with the housing development around Hart's Ponds, how is that construction affecting the watershed?
Well, our water quality is still A1, it's still top.
Total,
Well,
because of what's being taken from the ground.
We have limited authority over there. We do have some watershed rights, but that is the town of Berlin. Yeah, so we have some limited authority out there. We do test our water quality. We do receive plans on that. We review them. And anything that's objectionable, we'll raise. So again, it depends on what's going in there, but we do take a look at it. And the water quality has been quite well there. Hart's Ponds is a great source to have when you're in trouble, but it's very expensive to bring that water over to Wausau. You have to pump it. So we don't really utilize it unless we need to.
The other part of your question on the efficient toilets, it's something we can consider, something we hadn't really talked about internally yet, but something we can think about.
When I first came here back in 2001, about 2003, 2004, we tried to do a conservation program, and we bought 1,000 kits. I still have about 300 of those. We advertise and we let people know. We didn't get a lot of feedback. But our standards have changed, and they're required by state standard. We went from toilets that used to go 5 gallons a flush, now they're about 1 gallon a flush. So those things are constantly being addressed. One of the big things for us is pervious pavement. So when we have those stormwater issues, that groundwater goes into the ground, not into our storm system or our sanitary system. Those are the things we're trying to address right now.
Thank you.
We'll get to it, Paul.
The lining of the laterals, is that available to the, or is it too cost prohibitive to homeowners?
It probably would be too cost prohibitive for you. It's,
Which way are they lined? Do you go with the flow or against the flow?
it goes from the main back to the property. Yeah.
If you're going to do, the homeowner's much better off just replacing the line than doing a lateral thing. We're doing that as part of our sewer main lateral. We have the equipment in place, and we're doing that to extend into the lateral. But if you are a homeowner trying to do that, you're much better off just replacing your entire line. Yeah.
The companies like that do that kind of work just are typically doing more larger scale construction projects, and they're in a main and doing several along the course of that main. So.
Now, I live in Berlin, but are we responsible, as opposed to the water, are we responsible down to the main on sewer?
You are.
Okay. As opposed to the curb stop?
On the water in New Britain, we have the responsibility of the owners from the curb stop to the
From the corporation stop?
to the home.
Britain all the way to the main as well?
Buy the insurance. Yeah, buy both insurances. You get a break on both.
Yeah, we have brochures for both water and sewer out there. I'm sure bloody some, but
I have
Actually, Paul was first.
One, I just want to echo the comments of Dr. Judd. It was a great presentation, well done, thorough.
Thank you.
And it was pretty nuts and bolts. Easy to understand. But a question I have is I do appreciate your comments that we stand on the shoulders of our forefathers who have done some great things. And I heard you extolling the virtues of buying 1,000 acres of land in Lamson Corner in 1900. Patton Brook Well was put together. And those are all positives, but, I'm just looking at the PowerPoint presentation that was done at Gaffney School 6 months ago, and those two assets were completely downplayed in terms of saying we need the Tilcon Reservoir, and it was minimized, and I'm looking at this is from the PowerPoint presentation. It says Lamson Corner is not a realistic option, and I'm hearing something here today. And so I guess my question is the land and the water resources that our forefathers obtained 100 or 100 and some odd years ago, are they or are they not valuable resources? And if they are, should they be protected and preserved now and forever? And I'd really like to see a commitment here from all the people in this room and the city officials to say our forefathers did great things, which you said, but I haven't seen the commitment toward preserving that, because what I was hearing today is different as to Lamson Corner and Patton Brook than what I was hearing 6 months ago when Lennard Engineering was pushing the Tilcon proposal. So I'm having trouble reconciling what's being said today versus what was said 6 months ago.
Well, Lamson Corner is a great piece of property, but environmentally, it's very, very sensitive. 100 years ago, we didn't have the concerns that we have now, all the regulations that were in place. We looked at Tilcon Quarry, and there was a number of issues there that had to be addressed to make sure that everything we got. Those issues are going to be tenfold, especially environmental sensitivity. There are a number of different species out there that are much more sensitive to any change. And if we were to flood that area, a number of issues that would have to be addressed. We'd have to change a highway, Route 69 would have to be moved. So,
But you would have DPH approval, which Tilcon was not going to give you DPH.
well, I don't think we have. We'd have to go through the whole process again. It'd probably be actually more complicated than doing the Tilcon. I don't really want to discuss Tilcon. It was a bad time in the last 6 years. It was a very tough.
It was a bad time.
Well, I will. Go ahead.
Yeah.
Tilcon's dead.
Yeah. I mean,
It's stay dead.
You said that in 2007.
there's no plans to do anything for Tilcon, and we're really to discuss moving forward with the water department here today. I think the only thing, like when you talk about water, what is unfortunate for the city's water assets, because it's an incredible asset. What is unfortunate is that we don't have more capability. So we're at 100%. We were at a drought a couple of years ago that basically we were at 20%. We had to rely on outside source to. If we had more capacity to store water, we've been at 100% and just letting water, from all our assets, just drain for months on end. And so that is an unfortunate thing, but it's not, doing anything else to correct that or address that is very difficult.
And Paul, I want to address again the idea of the Whitesbridge well field it's really important for our future. I mean, that having a potable backup system is so important to the future. We need to have more control of our destiny, especially when it comes to our water supply. And that's where the big push is going to be for right now. I don't want to hear Tilcon anymore. I've got about 10 more years of my career here, and I hope I never hear Tilcon again. Yes, Bill. I'm sorry. This gentleman first.
Just a tiny question. I have the sewer and water line insurance programs. Every 3 or 4 years, I have to have the sewer line maintenance.
Mm-hmm.
And my question is, I know there's infiltration in my property. Would our insurance program cover if I had them come in and replace that clay piping that I have? They said it's crumbling.
If it's crumbling, I think you can make a justifiable case to
I think there's a cap on the insurance. So basically, if you're doing a full repair, I don't know anything about your property, how far it is from the road, it would have a cap. The lateral insurance is more set up for repairs instead of a full cost of replacement.
Okay.
So that's just something to know about the insurance.
It sounds like he needs a repair. Okay, Bill.
Back in October, Bristol reported a problem with E. coli in some of its wells on Big Street. Do we have a similar problem?
Not in our well. We don't use well water. Our plant is fantastic. We kill things two ways. We use ozone and we use chlorine residual. They were a well system. And to be fair to Bristol, It was a new requirement that was changed. A few years ago, the EPA created what's known as the groundwater rule. And it basically says if you have groundwater, if you have E. coli in your groundwater system, even though it's before treatment, before you can kill it, you have to report it to your individuals. So they had to do that, even though they had the treatment in place to make sure that it was safe. Yes, Paul?
It just,
Okay. It's this Paul Zagorski.
Yeah. Somebody asked, what protections do you have, does the city water department have in mind from Coppermine Brook and Bristol? Because I think both New Britain and Bristol are allowed to pump from Coppermine at some point, because I think that's a drought management area. So is there, you working hand in hand with Bristol, or you just...
Well, I haven't worked with them, but I've worked with the EPA, DEP, and some of the people of the health department. We have a registration there. We have rights to use it.
Yeah.
And the only time we're going to ever use those rights is when we need the water. Yeah, so we are good stewards out there. We're doing a lot of work out there. We try to do as much as we can. We do release water from the Wickville Reservoir that goes down into that. So we are working on it, but do we have a comprehensive, total, encompassing plan? Not as yet. Yes, Lee.
I want to make sure I understand this technically, but I understand that the loss of water, clean, potable water, from buildings and homes, right? What you're calling through the lateral connection.
Yeah.
Right, is putting a demand on the system. I mean, that costs
Absolutely.
us money.
Absolutely.
And this is metered water?
No, it's not metered.
No,
That's the problem.
Okay,
So we're not getting, it's unaccounted for water.
Right.
It's,
So you're getting a handle on the percentage of water that is lost
correct.
through this I&I.
It's
So
basically a conservation.
you're talking the sewers, because we have the opposite issues on water and sewer.
I'm losing water, he's getting water.
Right, right. On the sewer side. What it is clean, expensive, potable water is going into the sewer.
Well, it's not just clean. I mean, it's not just water that we came from the treatment plant. It's just groundwater that came from rainwater. That's infiltrated. That's probably the
What we're losing
bigger
doesn't
source.
match the 6 million gallons a day that he's getting. When we were at our peak, we had about 1.5 million gallons. He's getting 6 million gallons. So there is some controversy, and some of that is going into the stormwater system, and some of it may be going to the sewer system.
Right.
So
Right.
you can't really, they don't really equate.
Right, so but the water loss at the building site, that would cost building owners and homeowners a lot of money to help partner with the city to stop the leaks.
Yeah.
Am I right about that? What's the incentive for the city to come up with some sort of a plan to fix the leaks? And is it
On your
is it
service
worth it?
laterals, so basically, there's a couple things. We're under consent order for EPA to reduce our I&I. So, I mean, right off the bat, we're required to do so for EPA. The service laterals coming from properties are making up about half of the I&I into our system. So we need to address the lines coming from houses to the main, which we haven't done before. We have to do that. If we have any chance of addressing our I&I issues, we have to get into the service laterals.
You're talking about the water end of it, though, not the sewer.
I think we're talking about sewer side. We're talking about both. And on the other side, I mean, basically, the water we're losing in the sewer laterals, which is about half of our water loss, that's water that we're treating and sending out into the system.
Drinking laterals.
Yeah, and the drinking laterals. I mean, that's water that we already went through the process of getting it from our outside sources, brought it into the treatment, into the reservoir, treated it, sent it out. I mean, it makes no sense. I mean, we have significant effort invested in that water already. We need it stuck in our system.
Right, so that sounds to me like a project.
Oh,
Task force should be assigned that educates the public every step of the way, what's going on, what we are all losing.
Yeah, I mean, that's why we're here today. That's part of why we're here today.
We've addressed almost a third of that already, of that loss. The big thing is the homeowners, and it's a financial strain if you don't have the insurance. So we're trying to work out, we just sent out letters, we're trying to work out payment plans with people, because it is their responsibility by city ordinances. And if we can, we will help as much as we can. We work out payment plans. We're trying to look into some financing, but it's a tough issue. I must say that in our audit, when we first got the audit, we thought it was going to be a much more massive problem. In total, it's about 60 properties. Some of them are losing up to 10,000 gallons a day.
These are residential or?
These are residentials, mostly residential. Older piping system that has to be addressed. And again, it is a waste. And again, the chemical cost for our treatment is about $50 for every million gallons of water that we provide to make safe. It's about $50. But again, the cost for pumping it is the expensive thing. Especially if I have to pump it from one of our reservoirs, pump it into the treatment plant, get it into the gravity, pump it up to the tank, get it into the system, then pump it up to the high service water. That's 4 types of pumping. So that water becomes really expensive. And losing that, just coming out of a pipe, is an incredible waste. So that's why we're focusing on that. And yes?
Just a question is, I know that I give Lenard credit for doing that, but this problem has been existing for such a long period of time. Was it something that Lenard should have picked up, or somebody should have picked up? This didn't happen today.
I'll take this one. So when I talk about that, because you're right, this problem existed. I think in my mind, this should have been part of our utility operations a long time ago. Okay, and I attribute that personally to having new leadership in the utility division. Ray recognized this problem. He made a point of it. He was talking about it, and what he implemented this as a project. We've been taking on all the repairs in house to the mains. I purely look at this as this Whitesbridge pump stations. These are some really good initiatives, really important initiatives that we're taking on by the management of the water operations, and I agree. Probably should have been taken on several years ago. It wasn't, and I attribute that to Ray, totally. Jerry.
Change gears a little bit. On a national level, cybersecurity is a huge issue. So is water protection. Chicago was contaminated a little while ago. What can you not tell us that you're doing for security, just so we know that
I can tell them that.
where we stand on that?
I can't tell you anything. No, we're looking at some very advanced security systems. Cybersecurity is going to be the most important, especially we have to automate the plant. Cybersecurity, we're looking at triple layers of protection, encryption, passwords, maybe biological, some other things going through. But we are looking at that very, very closely. It's an important thing. There's a story that a lot of people don't know about. There was a utility which they created a fictitious name that was taken over by a hacker from somewhere in Central Asia, and they screwed with their chemical process. It's a very interesting story when you read about it. Yeah, we have to be eternally vigilant, but we can't stop our lives.
Any other questions? Yes, sir.
Yes. The building and that painting that's in the middle of the reservoir, it's pretty, but what's the story behind it?
That was the original plant. That steel structure.
The gatehouse?
Oh, that's the gatehouse. That's still out there. We have a pipe that goes into that building, and on the side of the walls we have different gates that we rise and lower, so we can take water from different levels, depending on the physical or the chemical properties of the water at that time. So sometimes it's better to take from closer to the top, sometimes it's better than in the middle, and when you really have to, you take from the bottom. We usually operate it in the middle section because that's where the thermocline is. We get less chemical differences between the hot and cold water. So that's what that building is.
And it's actually still in use?
Absolutely. And that's one of the things we, in our long-term plan, just to do some maintenance on it and upgrade that. Yes?
What is the average depth of the Shadow Meadow Reservoir?
25 to 30 feet, something like 20. It's very shallow compared to other lakes of its size. I want to say the 25 is the average depth. I think its deepest parts are about 35.
There was a comment made about adding more capacity to store water. Has the reservoir ever been dredged?
Not to my knowledge. It's one of the things we're looking at, but it is really, really, really expensive. That's a huge reservoir, a large surface area, and to go down there and dredge it, it's going to take quite an effort.
Could any of the 7 reservoirs be expanded in any manner?
I would love to expand Wigville, but it would be, again, a monumental task. The permitting process alone, the environmental impact, all this would be studied. Again, as I mentioned earlier, Wigville seems to be like a thimble in a blanket. It's got a huge watershed, but it's very small holding. It only holds 57 million gallons. I've seen that place go from dry to full in a good rainstorm. You know, it's incredible. That if I had my druthers and if I could do it, that would be the one that I would work on.
How would you increase the capacity of Pettinbrook well?
I'd probably get better pumps, re-drill the well. I have the rights to the area, and see where we can. That is a good aquifer, but again, more importantly than the aquifer, the capacity of that, is upgrading that facility. The pumps really need to go. And my understanding from when I talked to the people at Southington is it really needs to be rehabbed. The whole well structure itself has to be basically abandoned. The grease screens are falling apart, it's clogging. It's got some great water quality because it can be used directly as a feed, a potable source. The problem for us is it's too far away from our distribution system. It was used as a raw water source. I'd have to run, I think, a 4 or 5 mile line just to get it to our distribution system. And at $100 a foot, we're talking a lot of money. Alderman Francisco.
It's more of an observation very quickly, and I think, first of all, commendations to the overall presentation. All of us here who are the generalists by comparison to the specialists, I think it's really good to hear what you have to say as the professionals, oversighting everything that we're doing here in the city. And I think the big caution for me is that we're really looking at long-term costs if we're going to maintain the water supply we have. And I think that's where we all kind of unite together to say, how do we do that in terms of resources and potential revenue? And I just think that really comes out real clear in this whole presentation. We're dealing with older infrastructures, as you said. We've got issues that are coming down the road. And we've kind of, I think, been put on notice as a public to recognize that. And I think that's a good thing, to be aware that we can start planning. And so I commend you for that. I know the oversight, I think the thing we all have to accept is we have some oversight going on in the professionals who really know what they're doing. And I think that's important for all of us to hear.
Thank you, Danny. Alderman Santiago.
All right, a couple of questions. What are we doing for, say, for instance, buildings or resident houses that are not being used, and then when somebody, say, for instance, come in and buy those buildings out, are we doing any requirements to check those source lines and water lines so that way those are taken before that becomes usable again? You know, for instance, we'll say like houses that have been empty for a long time, so now you know that those systems hasn't been used for a while. Are we doing anything to make sure that those places?
I mean, that's not, like, I think Ray's going to answer.
That's more of a building department issue, but water lines going into those buildings are usually cut off by our meter division. We actually cut them off, we charge people for that. And it's better because if they don't use water, we still charge them for meter use, and they're responsible for the service line. So typically what we do on a property that is either going to be demolished or condemned, we cut off the service at the street, and then we'll reconnect once a new building's in place. So we do that, but the actual interior, that's a building department
What
issue.
I mean is, I'm talking about the lines that are in the ground. We're talking about from home to sewer lines and home to the water line.
Well, we
Those
shut.
lines are not been, they are shut off, but they're also sitting for, say, a moment of time.
Yes.
We did do, I mean, that.
I could get, when I.
This is Alderman Santiago. This is one of my commissioners, Mark Zanobi, actually 28 years with the water department.
But years ago, they used to, if the bank owned the property, they would go in and winterize the house.
Right.
And they shut the water off, they plug the line, and they drain all the water from the system, and then they just leave it and they sell the property.
And if they don't cut them off, we still charge them for a meter every month. Yes.
I think the question that Alderman's asking is there anything set up so that after they've been off for so many years to do a test before they go into service?
Before they start, before the system actually, before the buildings
That's
are.
not a bad idea. I don't know how we can enforce it, but because obviously it's not leaking because you shut it off.
Right.
You don't know when you
Sitting
turn
there
it
for a
on.
long time.
But it's tricky for us because, I mean, through the leaks, audit, we would know if their service lateral had a leak. I mean, once you get into the property itself, it's just like we supply, I mean, basically our responsibilities are up to the main, but then also we look at the leaks up to the property. That could be maybe a health department issue, but it just like, it's beyond where we really look at.
The second thing was the new developments, new housing, new buildings. What codes and regulations are there being input for those, so that way the plumbing that are going in, the outs and ins are for, say, certain amount of years or something, you know, so that way.
I mean, it's really like a building code issue, and it's
We have a set of standards, but just building code.
it's just different than what we deal with
But
specifically.
what I mean is, you're gonna deal with this, but they're gonna be dealing with it, you're gonna be dealing with it once the system is up. The house is up, the building's up.
Yeah.
So, I mean, I would think you would.
We have standards in place that they have to follow.
I mean, it's just like, but clearly, if you build a new house, you have to, when you submit site plans, you submit plans to the city. They're reviewed by the building department for compliance to codes. We have we have plumbing inspectors, we have electrical inspectors that go out there that make sure that you built to current codes. It's just handled by the building department, not by like water operations.
You don't oversee those?
No, we don't.
We do get copies of the plan to make sure that they meet our standards.
What's used,
Yes.
what's used for laterals now? Is clay pipe gone, or is that still
For sewers?
for lateral?
Plastic is used for PVC.
Oh, PVC.
And then for water, Dave?
the water service, we don't allow plastic. It's low carbon.
Right. Many years ago, it used to be galvanized, and in some cities, lead.
It's still bell joints and,
Not, maybe on the larger lines, but on the smaller lines, no, we just run it. Yeah.
Any more questions? Yes, sir.
Are there any combined sewers still?
No. Actually, that was one of the smart decisions. And actually, it's like right from the beginning. Some cities went in and put it combined sewers. Britain's sewer system was always independent. What it did have, and that's a testament to decisions forefathers made, but they did have some manholes that had an overflow, and basically those have been sealed, so they're independent. But we never had combined sewers in the city. Anything else?
This is a dumb question, but where does the storm water go?
Oh.
Ideally?
And
Is it the Connecticut River?
in any of these, so basically, as they're highlighted, all the different areas, so this area, all the stormwater from that ends up in the Bass Brook. What I didn't mention actually in the downtown area, and this is one of the interesting things about the storm sewer, the Piper Brook runs under the downtown for this entire length. There's basically a river going under the downtown. And if you pop manhole covers on East Main Street, there's like major pipe going on down there. All this stuff happens underground. You don't realize that at the surface what's really happening under there. Oh, yeah. But that's what it is, and that's why we get into something.
It does end up in the Connecticut River, though.
Yeah, eventually it ends up in the Connecticut River.
As you saw in my study where we were talking about that storm, everything drains towards the Connecticut River.
All set on questions? One more?
Mayor, do you want to say anything? Oh,
I wanted,
Bill?
What percentage of rainfall actually is runoff today? I think in 1960 study said about half the rainfall in the city ran off into the sewers into the cities.
it's probably a little more than that. I mean, it's basically, so if you have impervious area, like a rooftop, or it's like almost 90%. So the city has a lot of impervious area. I would guess it's probably about 60%, but not enough water is definitely infiltrating into the ground. We all set?
No, I just want to address that issue of 50% was what was used as the engineering standard at the time was called the rational method, where you would measure the amount of land that you would have and take a best guess estimate of 50% of it running off into the ground.
I do want to just take the opportunity to thank Mayor Stewart. She said that there's a misconception about some of the things that we do. She had the idea that like having something like this, like there's just not enough people in the city that understand the water, either the water operations or sanitary sewer operations. So that's what prompted this. I think it was a really good idea. It was a learning experience for both Ray and myself, but I think I hope it was for you as well. And with that, yeah, Ray will have anybody who wants to take a tour. He'll be giving a tour. I guess we have one more question.
Hi, I'm Lori Baffert from the State Health Department. I want to thank the mayor and I want to thank Ray and Mark and everyone here. There's not, as you just mentioned, to go through and step through what you've done over the last couple hours is really important for people to hear and understand, because a lot of this infrastructure is buried, or you drive by it, like you drive by that Bassett on Route 9, and you see that, but a lot of people don't realize the importance of it and all the good work of all the engineers and the people, the utility people that do the work. So from my perspective, it was great for me to sit and listen and hear this. And you don't hear enough of this kind of presentation, because what you do here in New Britain is replicated across all other towns and cities, and to get out and have the public come and sit and listen and hear the costs involved. You know, that's what's striking to me, is the costs. The aging infrastructure issues are prevalent in our state. And so, but I thank you for inviting the health department here. And it was really well done.
Thank you so much. I appreciate all of you.
So we'll be having a tour out there, but before you leave, I just want to say one thing. All the work that Mark and I do cannot be done without the staff that we have. We have some great people working for us. They are committed, they are dedicated, and they take their jobs very seriously. So please, don't forget about our staff. Thank you.
Thank you. Okay.
Hold on.